So, timber products, excellent, sustainable product. Now, technology and ways of using these are improving all the time. So not only have we got stud work covered, floors and voids covered, we've also now got retrofits. Retrofit is a great thing, and installations play a huge part in retrofits. Matter of fact, it's the main body of a retrofit, is insulation. Nowadays, there's even a timber product which could be used externally. This is actually used for retrofit. It's an external insulation, quite dense, high resistance, good R value, but this can be rendered on with a resin render, a breathable render, put over the top. One thing we do need to remember about insulations, especially natural insulations, they need to breathe. Everything around that insulation will be designed for it to breathe and to react naturally. So even external insulation retrofits can be wood products, timber products, earth products. That leads us on to other insulations which are more commonly used and better known, and that is EPS, expanded polystyrene, to thermal sheeting. These are usually foam, which are sandwiched or contained within paper or foil. These are excellent products. They're very, very good. They've been used for many years and got a really good proven track record. The advantage with this is that solid boarding like this, or solid sheeting, can be cut to width. You can cut it to angle. You can fit it very nicely in between rafters and joists. You can even, if you cut it in tight enough, suspend it in between ceilings. So it's really good stuff. It all has its uses. EcoBead. EcoBead is a product that's been going around for a few years now. I've used this many, many times. The great thing is it's totally recycled. It's an EPS. People say expanded polystyrene is not good for the environment. Once it's got further treated down the line for your packaging in your boxes, then yes, it's not very good. But this is a natural product. It's a recycled oil. It's just filtered and blown through high temperature steam, and it forms the EPS balls. And then that is pumped in under pressure and sprayed with a glue. And then as that goes in, it's set solid. And you can take the boards off, do whatever you like. It will remain in there. You'll get zero slump. Was the video not working? Video's not working.
Yeah, well, what we could do is add it to it.
Yeah,
so maybe just make reference to the video as if it's there.
Yeah,
we'll add it.
As the video runs, you will notice that because of the glue around it, it doesn't fall apart. It moves very, very slowly and deliberately like lava. And it'll actually pass the hole without dropping out. It will actually pass the hole till it hits an object. Then it will change direction and come out through the hole. So it's very, very good. Fills up every space that you can get into, provided it's under the correct pressure. When it comes to fibrous insulations, the wood fibre, whether it's glass fibre or wherever it may be, it has to be entered into a void somewhere. This is most commonly used on cavities or closed panel systems. So this is how it's basically used. This is one of the machines that's out there. This is the Fibre Master. What that does is it takes the fibre, you put it in through the top, it breaks it up, mashes it all to independent fibres, and then it blows it out under pressure. Now, we have to use machines like this to fill these cavities and voids because we want to avoid slump. What slump is sometimes on a build when you get a fibrous or a insulation, what happens is over a period of time, vibration and movement actually condenses the insulation within the void, and you get cold spots around all the levels. So how we compensate for that is we make sure that we get the correct amount of insulation in the void by calculating this area. We get the correct volume, in other words, that it goes in under the correct amount of pressure, and we get the correct volume for that area and the amount. So that actually guarantees that when this moves in a panel system or whatever, or over time, it's not going to drop and condense, and we're not going to have those voids form. So this is a way of controlling that. We can control the rate, the pressure, and volume by a machine similar to this. Structural insulation. Sometimes we have to put something on something, and that could be steel, it could be RSJs, could be timber rafters, could be purlings, could be anything. Actually, here we have an example of a metal post actually put onto an insulation. That's a structural insulation that will not compress. This is a fiberglass or a glass foam. This glass foam is produced to be able to take a weight only in one direction. It's designed to take a weight in that direction. But this is actually designed to be a thermal break within blockwork and brickwork. They build walls on top of this. So structural insulation, regardless of what you need to do, whether it's a steel, timber, brickwork, posts, then there is an insulation out there. Now, it has to be researched. You need to look and research what is going to be the best structural insulation for what you need for the way that you're going to use it. But whatever you're going to do, there will be a form of structural insulation out there. Even under doors. Under doors, we use a foam glass because it's good insulator. We can cut it to size. We can cut it to width and height. And it's very versatile. That is structural insulation. Now, there's no point in doing all this insulation and saying this does something unless we actually prove it. How do we prove it? Testing. Testing the thermal envelope. Now, there's a couple of little samples here of heat loss and heat retention. This is offering a good R value, a good resistance to the loss of energy, where this isn't. It's very evident when it comes to testing. Every property, regardless whether it's a new build or a retrofit, needs to be thermally imaged. They do this by heating the house, potentially up to about 50 degrees, depending on the temperature outside, leaving it for about 4 hours, and then thermal imaging it, and seeing where all the heat is coming out, where you're losing the energy. But testing is key to proving that something does what it says it's supposed to do. Thermal imaging. Most insulations are safe to handle. Now, we're going to go about health and safety because it is an important part of any insulation. All insulations will create dust of some description, whether it's a fine dust, heavy dust, doesn't matter, or whether it's a natural product, an earth product, or a glass fiber product, it will produce dust. So follow your personal protective equipment, your PPE, and use it safely.
Sure. John, you mentioned R values, and I just wanted to draw that out. Obviously, it's something that you discuss a lot. Just wanted to understand the relevance of knowing what an R value is.
R value or A value, we'll talk about values in general. Everything has a value. Regardless of what it does, how it reacts, or whether it's hot or whether it's cold, everything is measured in value. We're all very used to the U value. What is a U value? Well, that's how much energy is lost through a product or through glass, whatever. Your U value of glass is this, because that's how much energy you're losing through the glass. That's your U value. So the U value, lower it is, the better it is. The R value is different. The R value measures how much resistance is going to give against energy or heat loss. So R value is your thermal insulance or your thermal resistance. The higher the R value, the better the product.
So the higher the R value, the lower the U value.
The higher the R value is, the better the U value will be.
And we want to have an understanding of these values. Am I correct in saying it's more applicable to a designer to know the R values and U values and really assess and understand them?
Yeah, there are any values given you. We have a number of values to which we use. The U value, R value, K value, Y value. They're the most common ones that you'll hear. As we go through the different descriptions or the different materials and methods, we will be talking about the values just to so you can identify what it actually means. Because on drawings, paperwork, structural engineers' drawings, that type of thing, you will see values. So it's just a good idea to be able to have a basic idea of what that means.
Excellent. Do you want to go to the image of the north insulation where we've got handprints there? So, John, you can see the centre image there is the recycled blown glass. And I can see, you might not pick it up, you can actually see that there's handprints in there. I just wanted to draw reference to that and just let you discuss that a little bit in terms of the makeup once you've blown it in. And
what this is we've got a few different insulations here. There are many, many different types out there. We can't show all of them. So I've given what I think is a range. Now, these are obviously sheet materials, different types of sheet material, but they're sheet materials. But this is a blown glass. This is the Knorr insulation for glass fibre. Now, what this is, the reason there's handprints on there is this was boarded. We screwed a board onto a panel. We filled it full of glass fibre. And then we took the board off to show the density and how it works. So we actually took the volume of this cavity and we calculated how much we were going to need. We calculated the pressure it should be under, and we calculated the rate it should go in at. So once we did this, we took the board off, and my demonstration of how dense it is putting my hand in there. And that's why you see handprints. It shows the density of what you need to put in there. But that basically shows that it's not going to condense and compact within the void over time.
Excellent. And that thought process requires calculation. You need to understand the flow, the volume, and
yeah, you need to understand volumes and flows. The reason is because every product has its own unique way of working. They all respond differently. So you can have 5 different fibre products, and those 5 different fibre products will react differently. So each one you will go to the recommended advice of the manufacturer. Every process and product will have its own recommendations by the manufacturer. Follow them and you won't have any issues.
Excellent. And you made reference to it, you did speak about it, but I just thought I'd touch on it again. You mentioned blown in. I just want you to just explain the process of that and just sort of spell it out a little bit. There you go.
Right, when we blow fibre in, it's basically any fibre that you put into a cavity, whether you put into a void, whether you put into, as in here, a closed panel system. It has to be filled, as we said before, to the right density to stop that slump and making sure it does the job that it's supposed to do. And that's why we use these machines. This is just a basic representation of one machine. There's many different types. This is the one that we use here. It basically, we load it up with bales. Once those bales have gone in, the machine breaks it all up and brings it back down to its fluffy fibre content. And then it will go through the machine, and at the bottom here, we can control the air pressure and the product flow. And then that way, we can make sure that we get the exact amount we need in there for the correct pressure. The machine can do that for us. We just have to do the basic mathematics.
Excellent. If you just go back to, is it the earth fibre or the wood fibre? That's it. John, you mentioned in these examples sudwork, boards, and then you talked about voids. And I just wanted to sort of slow it down and spell it out for us.
Yeah, I mean, these products will be used the same as all the other products that you see. The difference is these are just an earth product. They're wood. They're a timber product. They're just wood fibre. But they were used in exactly the same way as any other insulation. It's just whether they're the right insulation for what you need for your project. So this is good for stud work and between joists, the same as the other glass fibres are. This is actually a really good interlocking thermal board. This is strong enough to walk on. So this is a good insulator for a concrete floor or something like that. And this is a fibre. The same as the glass fibre that went in with the blowing machine, this goes in exactly the same way. And it's calculated and used in the same way. It's simply just a different product to do the same job. Insulations, they're designed to do one job, keep heat in, to give a good resilience to heat loss and energy loss.
Excellent. We will be talking about cradle to grave. And I just thought it's worth just touching on the difference between certain products in terms of the cradle to grave calculation.
From cradle to grave, these are calculations or the lifespan of a product and how it will perform over that period of time. So different materials respond differently over time. And a natural product, an earth product like this, would resist or respond differently to certain environments than glass fibre may, or something like that. So different products will be a different ratio in the from cradle to grave calculations. So you have to make sure that what you use is right for your job.
Yeah. So just touching on the eco bead, you talked about the zero slump, and we have touched on that, but just explain what slump means. And
Slump. I talk about getting to zero slump. That simply means that within a void that we don't get any drop. Many things over the years tend to compress and compact and drop and create gaps and voids. We want to avoid that wherever possible, and we do that by following the guidelines by the manufacturers and looking at the products. The Eco Bead's an excellent one because it goes in under pressure, but it's also got an adhesive, so it sticks together. It breathes, and also it doesn't allow water to penetrate. These products are different. They still go in under pressure. They still have to be put into the correct amount. They will not slump if they're done correctly, but they have to be followed by the guidelines.
Excellent. You talked about structural insulation. I'll let you hand up. Yeah, but when you was discussing structural insulation, you mentioned that it only takes the force in one direction. I just wanted you to maybe explain why that is. And
yes, some insulations, especially structural insulations, will only take force in one direction. That's because they're designed to do a specific job. Okay, like the foam glass, excellent insulation is really good because we can cut it to any shape and size that we like. but it's designed to do a job. It's designed to be a thermal break between brick and block work. There's walls built on top of this, so it's designed to take the pressure in one direction. So we can cut that to width and height as long as we keep it the right way up. It's not a problem. Other installations like this one, you don't cut this. This is ordered to size and shape. Even the holes potentially going to be pre-made in this. So therefore, you cut this very good insulation and it's excellent structurally, but you may be able to put different pressures on it from different directions, but you can't cut it. It's pre-formed and pre-made. That's why I've got two different subjects up here, because they're both very different, but do the same job or a similar job.
Yeah. With the knowledge that I'm developing through, working with people like yourself, John, I'm seeing now when I go and see buildings and I can see that they've got a metal beam and there's no structural break, and I just can imagine how difficult that would be if you wanted to put a structural break there.
Thermal break.
Yeah, a thermal break, sorry. Is it impossible to do that? If say, for example, a building's propped up with a structural a beam, so to speak, a metal structural beam?
No, when it comes to existing steel, existing products and builds, it's particularly difficult to get a structural insulation in or around it. You may actually have to support it, take brickwork and blockwork out around it, and then put the insulation and re-brick it in. You get a really good result, but it's whether the thermal ability is going to be good enough to warrant the amount of money spent on it. Because there has to be some form of give or take, especially when it comes to retrofits. You're not going to get the same result from a retrofit as you are a new build, because you can't design it in. So therefore, you have to deal with each individual problem and come up with a solution for each individual item that may come up. And sometimes we can't do this. Other times, you may have a structural steel, which is a support post. You may be able to support that, break around it, and put this in underneath. There are insulations which are liquid. You can actually get a structural insulation liquid. They're few and far between, but it's a new technology that's coming on, and that's something to which we're going to keep an eye on, because there are new products coming on the market all the time,